A lot about the supervised learning algorithms where we have a given training data set, and based on that we try to find a mapping between the independent and the dependent variables, and then use that mapping to predict future values following that relationship. Okay, so now we come to the unsupervised learning where we have no label data. We only have some instances, and we know that they can be grouped into certain parts or certain groups. Consider, let's say I have a group of students in my class and I want to give a group project, and I have said that I will create the groups between them so that there are separate multiple individual groups for the group project, and I want to create these groups based on some properties. Let's say the students who know each other from before, or let's say the students who are having similar kind of interest or things like that. Okay, so I have no idea at the beginning which student should go to which cluster. I just have to know that how many groups I want to create. Let's say for my project I want to create, in my class project I want to create 20 groups. I just know k equal to 20. Okay, so based on that I'll do that. So unsupervised learning, the major technique is called clustering, where, as I said, we divide the instances into different groups. Okay, we have no classes to predict like we did for supervised learning before, using different machine learning algorithms. So now there is a iterative distance-based clustering technique, which is a very famous one. It's called k-means clustering. Okay, also sometimes called KMM, similar to KNN, which we have seen in the in the supervised learning. So k-means clustering, or k-means method we call it. So what is there are two parts. Okay, one is k, another is means. So first one is k. So it's like this algorithm can be explained in multiple steps. The first step is specify the number k, how many clusters you want to create. As I said, if let's say in my algorithm class or in my machine learning class I want to create 20 groups of project groups of students. Okay, so my k will be 20. But how to determine this? You have to know that value of k from the beginning. Okay, so how to determine the best k is not easy. We'll talk about it, how to find that. But after you have determine what should be your k, you specify that k, and then what the algorithm does, it randomly places some points on the space. It can be a multi-dimensional space, can be a two-dimensional space, like I have shown it here, when there are only two different clusters. So in this space it will create just two cluster heads or cluster centers, whatever we call. So next what we'll do, and it can be randomly placed. Okay, so let's see this example. There are multiple green positive and negative samples, and they are kind of mixed up. Okay, so now we want to place, like we know that k equal to 2, so we want to place two cluster heads, and they are randomly placed. You see, they are not placed in the middle, or they can be placed anywhere. Okay, so once they are placed, what we try to do, we try to assign instances to their nearest cluster. It's something like, let's say there are these are the localities, and they are like let's say Kroger near you, and then you always want to go to the nearest Kroger, like so that's why we want to assign those people who are near to this Kroger to this particular Kroger, and the people who are near to this Kroger to that particular Kroger. Okay, so now what happens, we calculate the distances between the so once we assign the instances, so once we place them randomly, we calculate kind of the distance, and then vertical line dividing the distance, and all the samples in this side are assigned to this one, the green star, which is the cluster head of the green sample or positive samples, and all the samples this side of the line are to the so you can see this red two samples are basically closer to this green one, and that's why they are kind of converted into green samples, although they are probably better classified in the red sample. Okay, so now at the step 3, what we do, we take the means of, let's say all these are green samples, so now we calculate the means. Okay, that's why it's called k-means. So this is like the the centroid of the instances. We try to find what is the middle point. Okay, the CG, let's say center of gravity of this, and then after we find that, we place it. So this is the center of gravity, and we identify this as the new position of the cluster head, which was before. So now this is the cluster head for this cluster, and this is the cluster head for this cluster. Okay. So now again we kind of find the distance between them and separate them in, and then assign those instances which are closer to this one, and all the instances closer to this as this one. So at the initial stage, initial runs of the k-means algorithm, there will be huge changes in the the error margin or the position of the cluster head. Now you see the cluster is more or less like center, but still we will again calculate the distances, the centroid of this, all the samples, because you can see this red sample which was green in here now again becomes red, because now it's associated with this one. Similarly for this one also now becomes green. Okay, so now you see there are two clusters, so cluster 1 and cluster 2. Now what we do, again we calculate the the means or the centroid of this positive samples and centroid of this negative samples, and then place the cluster head there, the centroid. Okay, so again the position of the cluster head gets revised and revised, and we iterate this process again and again until the position of the cluster head does not change at all. Okay, so you can see at the initial part the position of the cluster head changes more frequently, but in the later part the position of the cluster head hardly changes. Okay, then we know that algorithm has stabilized, and finally we'll find very uniquely identified two clusters. So now this clusters can also be, some people may think, oh, these are not two clusters, these are four clusters, there's 6 clusters, 3 clusters, depending on the value of k. Okay, k equal to 3 means 3 cluster, k equal to 4 means 4 cluster. But how do we know that which k we should choose? So there is a way, you see, we can calculate the error. What is the error? It's basically the distance of individual samples with the corresponding cluster head. Like for this green one with this green star. So, and similarly for all of them we calculate the error, and then we take the square and then sum them up. Okay, sum the total error. Similarly, we also do it for this cluster. This is, let's say, the second cluster. The cluster head is 2, j equal to 2, and we do the same. And then for all the clusters, so all the samples within one cluster, we do it, and then for all the clusters we do the same procedure. That's like double summation. Okay, this is for all the clusters, this is all the samples within one cluster, and if we add the error, we'll find that the total error. Now we check that how with the changing value of k the total error changes. We'll find that at the initial stage where k value is lower, this error rate will significantly drop. And then there will be one time when the error rate will hardly change. Okay, it will look like an elbow. Okay, it's like an elbow, where the elbow is the point where from the very the steep change, the curve error versus k graph will have a very less drastic changes, and that's called the elbow point. And that's the best place. Let's say this is k equal to 3. Let's say this is k equal to 3, and then we will tell k equal to 3. Equal to 3 is the best value for the k-means clustering, and based on that we can do the calculations again and find the 3 best clusters.